projects. In this video, we are going to see thyroid disease detection using machine learning algorithms. Introduction. The thyroid disease detection project is crucial for timely diagnosis of thyroid disorders which impact metabolism, energy levels, and overall health. By using advanced technologies like machine learning, the project aims to enhance early detection, enabling timely intervention and treatment. This improved accuracy could prevent unnecessary medical procedures and reduce healthcare costs, ultimately improving patient outcomes and quality of life for those affected by thyroid conditions. Objective of the project. The Thyroid Disease Detection Project aims to develop and evaluate machine learning algorithms like support vector machine, naive Bayes, and random forest for accurate thyroid disease detection. By pre-processing, training, and testing datasets, the project aims to achieve high prediction accuracy, aiding healthcare professionals in early diagnosis and improve patient outcomes, optimizing medical decision making for individuals affected by thyroid conditions. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDEL of Python 3.7 version. To execute this project, we have designed the following modules. The first module is Upload Thyroid Dataset. In this module, the project allows us to upload the thyroid dataset and displays its contents. By visualizing the count of normal and thyroid patients through a graph, we gain an initial understanding of the dataset's distribution, laying the groundwork for subsequent analysis. The second module is Preprocessed Dataset. This module is crucial for data preparation. It handles missing values, converts non-numeric data into numeric formats, shuffles the dataset, and splits it into training and testing subsets. The 80:20 split ensures sufficient data for training and evaluating the algorithms efficiently. The third module is Run Naive Bayes algorithm. Naive Bayes is a probabilistic classification algorithm based on Bayes' theorem. It is chosen for this project due to its simplicity and efficiency in handling large datasets. The module trains the naive Bayes model on 80% of the data and evaluates its prediction accuracy on remaining 20%. The fourth module is Run SVM algorithm. Support vector machine SVM is a powerful classification algorithm that separates data into distinct classes using hyperplanes. In this module, SVM is selected for its ability to handle high-dimensional data and provide accurate predictions. The algorithm is trained on 80% of the dataset and evaluated on the test data for prediction accuracy. The next module is Run Random Forest algorithm. Random forest is an ensemble learning technique that constructs multiple decision trees and combines their outputs for improved accuracy. This module adopts random forest due to its robustness against overfitting and its ability to handle large datasets. The model is trained on 80% of the dataset and its prediction accuracy is assessed on the test data. The next module is Comparison Graph. The Comparison Graph module creates a visual representation of the accuracy comparison between the three algorithms: naive Bayes, support vector machine, and random forest. This graph enables us to identify which algorithm performs best in terms of prediction accuracy, aiding in algorithm selection for thyroid disease detection. The last module is Predict Disease from Test Data. In this module, we can upload test data to predict whether individuals have normal thyroid function or exhibit signs of thyroid disease. Execution of the project. To execute this project, first we need to open the code folder. This is the dataset folder in which I have thyroid dataset, which contains more than 5000 records. So these are the column names and remaining are the rows containing dataset values, and in last column we have two class labels called P means presence of thyroid and N means normal. So by using this dataset, we will train and evaluate performance of all algorithms. Close this dataset, and this is the test data. This is the Python main code file, and this is the run.bat file. Instead of executing the project in command line interface, we have created this Windows batch file. Double click on run.bat file. graphical user interface will be opened. With this, we are interacting with the program. We have used Tkinter library to create this graphical user interface. Now click on Upload Thyroid Dataset button. A dialog box opens. Select the dataset and click on Open. So in this graph, on x-axis I have N, that means normal, and P means thyroid presence, and on y-axis I have number of records, and we can see there are more number of records showing thyroid presence. Close this graph, and in the text area we can see a confirmation that the dataset is loaded, and here we are showing only 3772 records, and there are 30 columns in the data. And we can see there are non-numeric as well as numeric values in the data. Now click on Pre-process Dataset button. So here we can see a confirmation that dataset pre-processing and normalization process completed, and here we are showing the only 3772 rows out of the total dataset, and the dataset contains 30 columns. The total dataset contains 6,962 records, and this dataset is split into train and test sets in the ratio of 80:20. So now train set includes 5,569 records and test set includes 1,393 records. Train set is for training the model and test set is for checking the performance of the model. Now click on Run Naive-Bayes Algorithm button. So in this graph, these diagonal boxes show the true negatives and true positive records, and these are misclassifications, that is false negatives and false positives. Close this graph, and in the text area we can see the accuracy, precision, recall and F-score of Naive-Bayes algorithm. Now click on Run SVM algorithm button. So in this graph, these are the true positives and true negatives, and these are misclassifications. And this x-axis represents predicted class and y-axis represents true class. And we can see misclassifications are reduced. Close this graph, and now click on Run Random Forest Algorithm button. So we can see misclassifications have further gone down, improving the accuracy percentage. So here we can see the accuracy, precision, recall and F-score of random forest algorithm. Now click on Comparison Graph button. So in this graph, on x-axis I have algorithm names, and on y-axis I have accuracy, F-score, precision and recall, and we can see random forest is doing well in all the performance metrics. Close this graph, and now click on Predict Disease from Test Data. A dialog box opens. Select the test data and click on Open. So in the square brackets I have test records, and after the brackets, after the arrow, we can see predictions. So for this test record it has predicted as normal, and for this test record it has predicted as thyroid detected. We can scroll down text area to see the predictions for all the records. The conclusion here is the thyroid disease detection project showcased the effectiveness of machine learning algorithms in early and accurate thyroid disorder detection. Implementing support vector machine, Naive-Bayes and random forest, the project achieved high prediction accuracy with random forest excelling. The user-friendly interface and valuable insights provide a promising tool for healthcare professionals to make timely diagnosis and improve patient outcomes in managing thyroid conditions.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.